today we were talking about quadrilaterals. So we've been talking about triangles, and we talked about quadrilaterals. And today we are talking briefly about polygons. We want to be able to determine the sum of the measures of the interior angles of any polygon. So, a polygon is a closed figure formed by 3 or more line segments called sides. So a polygon includes a triangle, and so we have special names, and the polygons are classified by those number of sides that they have. So if it has 3 sides, obviously, it is called a triangle. All right, if it has 4 sides, it is called a quadrilateral. Very good. Quadrilateral. If it has 5 sides, a pentagon. Very good. It is called a pentagon. That's Superman's famous logo. That's my, all right, Superman, you know, yeah, okay, it's pentagon, okay. If it has 6 sides, hexagon, very good. A hexagon, like, you know, when someone gives you a hex, like, and a 666, like, it's like, you know, yeah, so 6 sides is a hexagon. 1, 2, 3, 4, 5, 6, hexagon. 7 sides, do you know what a 7-sided figure is called? That one's harder. Maybe don't know that. 7 sides is called a heptagon. H-E-P, heptagon. So 7 is heptagon, octagon for 8 sides. Stop sign. That's exactly what I was thinking. I was just about to say that. Very good. Stop sign, octagon. Does anyone know what a 9-sided polygon is called? Nine is nonagon. Nonagon. Non for 9. And decagon for 10. Very good. D-E-C-A-G-O-N. Decagon. So dec is 10. And there's one more that comes up in delta math. So it's a 12-sided polygon. And it is a dodecagon. Dodecagon. Do as in 2 and dec as in 10. So 2 and 10 sides. Okay. So dodecagon is a 12-sided. We don't have one for 11, but we can have any sides of polygons. So you could have a polygon that has 100 sides. Can you just imagine a 100-sided polygon for a second? Does it look like a pentagon, or does it, what does it look more like? More like a circle. It's exactly right. So as the sides increase, so if you get like a 1,000-sided polygon, yeah, it really looks more like a circle because those sides are so small, okay? And so when we have other numbers, we might just call it an 11gon or a 23gon. So they just number the sides that way, all right? So you might have a 1,000gon, which would be a very, very crazy polygon, but that happens, okay? So our goal not only is to name, ladies, please, not only to be able to name our polygons, but we really want to know what the interior angle measures are. So we already know a couple here. So a triangle has how many sides? 3 sides. And obviously, how many triangles does it have? Just one triangle. And how many degrees does this one triangle have? 180, yeah. So we already know a little bit of information here. And what we're going to see is we're going to see a really cool pattern. We know that a triangle has 180 degrees, and so our polygons, basically, to figure out the number of degrees, we want to figure out how many triangles they contain, okay? So on a quadrilateral, I can pick one corner and just draw the diagonal. And how many triangles, well, first, how many sides are there? 4 sides. How many triangles do we have? 2 triangles. And if each triangle is 180 degrees, then how many degrees in all? 360, sure. Okay, 360 degrees. 180 plus 180 is 360. So let's look at a pentagon. How many sides does a pentagon have? 5, yeah. And so I want to figure out how many triangles are in that pentagon, so I'm going to pick one vertex. So I'm just going to pick one vertex, and how many diagonals can I draw? 1 goes to that. I can't draw, that's a side, so I don't want that first sort of diagonal. Here's one diagonal. Here's another diagonal to this corner, and then the last one here is a side, so that doesn't count. So how many triangles are in there? 3. All right, and each one of those has 180 degrees. What's 540? Very good. 180 plus 180 plus 180 is 540. Now, a hexagon has how many sides? 6 sides. Let's see, we want to figure out how many triangles we can draw. What's your guess?
6.
You think we can draw 6 triangles?
4.
4. Let's see, what can we draw here? I'm going to pick a vertex. It doesn't matter which one, but you're going to pick one vertex. We're going to see how many triangles we can make. Jace, I don't know what you're doing, but you should not be on your computer right now. Why don't you close that up? All right, thanks. Here we go. I can't draw this first line. That's a side of my polygon. So I can go to here. There's 1. I can connect here to make another triangle. I can connect here to make another triangle. And that last one is the side of my polygon. So how many triangles do we have here? 4. 1, 2, 3, 4. 4 triangles. And each one of those has a 180. So what is 4 times 180? 720 degrees. Are you seeing a pattern? Yeah? How did we get 540? 180 times 3. Yeah, because there were 3 triangles, so we just have to multiply that by the degrees in the triangles. Does that make sense to you? All right. What if we had a heptagon? How many sides does a heptagon have? 7. How many triangles is it going to have? 5. Okay. What's the pattern here between the number of sides and the number of triangles?
The triangles are 2 less than
2 less than the number of sides. Very good. And so to figure out the degrees, all I have to do is 5 times 180, and that's going to give me what? 900. Okay. Okay, so we have a lovely formula that we can use, and you guys just derived it. Ladies, now is not the time. This is the last time I'm going to ask you to stop talking. Okay. A very easy formula because it's based on the number of sides. So if n represents the number of sides of a polygon, what we want to be able to do is figure out the number of triangles. So if my number of sides is n, how do we get the number of triangles? I have 7 sides. What did I have to do to get 5? Subtract 2. So we take our number of sides and subtract 2. I'm going to take that. This is how many triangles we have. All right, that gives me the number of triangles. And what do I have to do if I know the number of triangles? Times by 180. So 180 times n minus 2, and this equals our S for the sum of the interior angle degrees. Okay? A very easy formula. So now we're going to use that. We want to find the sum of the measures of the interior angles of each polygon. What is a decagon? 10. So this is n equals 10 because it's got 10 sides. And how are we going to figure out our sum right? So we want to do 10 minus 2, and what do we have to do to 10 minus 2? Times by 180 in your calculators. You could put this whole thing in, or you can just do 180 times 8, and what does that give you? 1440 degrees. There we go. All right, what about for the 25-degon? How are we going to figure out our sum? 180 times 25 minus the 2. So we could do 180 times 23. And in our calculator, what is 180 times 23? 4,140 degrees. Okay? All right. Any questions on using that formula? Pretty easy, right? Woohoo! Okay. Super. Turns the page. Okay. We also want to be able to relate some polygons. So we are going to talk briefly about congruent polygons. What does congruent mean? Same. Yeah, they're the same lengths or same angles. Congruent just means the same. All right, or equal. Yeah. All right. So congruent polygons have the same size and shape. They have the same size and shape. All corresponding parts, meaning all sides and angles, are congruent, which, you know, in simple terms really just means that they're equal, okay? And the best thing to know is a congruency statement. A congruency statement looks like this. It says triangle ABC is congruent. This is our congruent marking, C-O-N-G-R-U-E-N-T. Triangle ABC is congruent to triangle DEF. Now, the order of this congruency statement is super important because it's put in order for a reason. What it says is that angle A is the same as angle D. They're in the first positions. Do you see that? And so you can see the marking here. Angle A is congruent to angle D. They have the same congruence markings. In the second position, we have B is congruent to E. And you can see in our picture here, B has a double arc mark and E has a double arc mark. They're the same. And in the last position, we have C is congruent to F. And so again, you see that they are triple arc marked. Those are matching arc marks, and so those are matching angles. In the same way, the sides also match, and you can see the sides come from the same congruency statement. A, B are right next to each other. That corresponds with D, E. They're the first two positions. So this is A, B corresponding with D, E. Does that make sense to you? In the last two positions, we have B, C corresponding to E and F. So here's B, C matches E and F. That's side, segment. And then we have the first and last position. A and C matches with DF. AC, 1, 2, 3, matches with DF, 1, 2, 3. So this congruent statement tells me all the matching parts, okay? So we want to be able to identify those things without a picture. We want to identify the congruent parts from our nice little congruency statement here. Angle W is going to be congruent to what? Yeah, angle Q. Again, they're in the first positions right there. Angle X is congruent to what? Angle R. Angle Y is congruent to what? Angle S. Okay. Y'all get that? Super easy, right? Order matters. Okay. Now, WX, that is the first two letters, what's that going to be congruent to? Yeah, segment QR. So segment QR. If they use a bar above, you should use a bar above. That means segment, okay? XY is going to be congruent to RS, segment RS. And WY, that is the first and last, is going to be congruent to QS, the first and last. So segment QS. All right? Will you take 1 minute and do number 6? Minutes, do number. Oh, nice. Okay. You got a pencil there, Mason? All right. Let's see. What does angle H correspond to? Angle M. Very good. And what does GH correspond to? Yes, LM. All right. So GH was the last two. LM is also the last two. Do you guys have any questions on that? No. Okay, great. So now we want to apply that same idea to pictures and their measurements, okay? So on number 7, we have a nice congruency statement. So what you want to do is you want to mark your picture so we can see what is supposed to match, okay? So let's see, angle P is going to be congruent to what? Angle T, all right? So mark your pictures, ladies and gentlemen. It is super important to mark your pictures. All right, angle Q is going to be congruent to what? Angle U, yes. Hey, if angle U is 21 degrees, what do I know? Angle Q is also 21 degrees. Mark your picture. If U is 21, Q should be 21 because they are congruent. So angle Q is also 21 degrees. All right, let's see. Last we have angle R is going to be congruent to V, yes. So I'm going to mark that with a triple mark there. Hey, if angle R is 129, what do we know? V is also 129 degrees. So V is also 129 degrees. Ladies and gentlemen, can we figure out angle P? How do we figure out angle P? Subtract from 180, yeah. We know that a triangle has 180 degrees. We're going to subtract 21 and subtract 129. So minus 129 minus 21, and what do we get? 30? All right, 30 degrees for angle P. What's angle T? Also 30, very good. Okay, now side lengths here. PR is the first and last. What does PR correspond to? PR, first and last, corresponds to T and V. Yeah, T with V. That's over here. So PR corresponds with TV. So you really have to use that congruency statement. So if PR is 10, what is TV? 10 as well. Okay. Let's see. RQ is right here. This is the last two letters. RQ corresponds to what? Right here, R and Q. So RQ, right there, RQ corresponds to what? UV, yes. UV is right here. So RQ corresponds to UV. Are you seeing it? Okay. All right. So if RQ is 13, what is VU? 13 as well. Okay. So UV is 13. All right, last one here. PQ is this long segment here. PQ is the first two letters. PQ corresponds with TU, the first two letters. So TU is right here. So those two segments correspond. If TU is 21, what's PQ? 21 as well. All right, so also 21 feet. You get that? You pretty good? All right, one more and then we're done. Let's look at number 9. All right, trapezoid more is congruent to trapezoid mass. That was so clever. Okay. Oh my goodness. Okay. So angle M, right here, I'm just going to put a dot, corresponds with angle yeah, got to be in the first one. It's also M. So these, why do those correspond? What kind of angles are those? Vertical angles, and they have to match. So this is also 108 degrees, okay? All right, angle O corresponds with angle A, yes. So I'm going to use 2 dots to mark those angles. If A is 125 degrees, what's angle O? Also 125. Ladies and gentlemen, I really encourage you to mark your pictures because it just makes life a lot easier when it's right there on the picture, okay? All right, angle R corresponds with T. All right. And then last we have angle E corresponds with angle H. So E corresponds with H. If H is 72, what's E? Also 72. All right, so E is also 72. How do we figure out angle T, ladies and gentlemen? Subtract from 360. Why is it 360? Because it's a quadrilateral. So minus 108, minus 125, minus 72. And what do we get? 55, I believe. 55. Check your math. Okay. Let's see. We want EM. EM is right here. It's the first and last. What does EM correspond to? MH. Very good. The first and last. MH is right here. If MH is 9, what's ME? Also 9. Yes. All right. And then HT. HT is these last two letters. What does HT correspond with? R and E. Very good. R and E is right here. RE is 23. So what is TH? Also 23. So 23. Okay. Do you have questions for me? No? Pretty easy? How do you find the sum of the interior angles of a polygon? 180 times n minus 2. Very good.